Welcome to our journey through the fascinating world of chemistry. Today, we're diving into the periodic table and uncovering the secrets of chemical bonding. Let's get started. The periodic table is more than just a chart, it's a roadmap to the elements. Here's how it's organized: rows or periods. Elements in the same row or period share the same number of electron shells. This defines their basic structure. Columns or groups. Elements in the same column or group have the same number of valence electrons, those outermost electrons that determine an element's reactivity. That's why elements in the same group have similar chemical properties. Next up, let's uncover the trends that govern how elements behave. First, atomic size. Atomic size. As you move across a period, atomic size decreases. Why? Because the nucleus gains more protons, pulling electrons closer. But as you move down a group, atomic size increases. This happens because new electron shells are added, pushing the outermost electrons farther from the nucleus. Ionization energy. This is the energy required to remove an electron. Across a period, it increases as electrons are more tightly bound to the nucleus. Down a group, it decreases because electrons are farther away and easier to remove. Now, let's dive into how atoms connect to form molecules. There are two main types of bonds: ionic and covalent. Ionic bonding. This occurs when electrons are transferred from one atom to another, typically between a metal and a nonmetal. For example, sodium donates an electron to chlorine, forming table salt, NaCl. Covalent bonding. Here, electrons are shared between atoms, usually nonmetals. Water, H2O, is a great example, where oxygen shares electrons with hydrogen. Not all covalent bonds are equal. Some atoms are better at attracting electrons than others. This property is called electronegativity. When one atom in a bond is more electronegative, it pulls electrons closer, creating a polar bond. For example, in water, oxygen pulls electrons closer, making one side of the molecule slightly negative and the other slightly positive. Here's a fun fact. Oxides can behave as acids or bases, depending on the element. Metal oxides react with water to form bases. For instance, sodium oxide reacts with water to create sodium hydroxide. Nonmetal oxides react with water to form acids. For example, carbon dioxide reacts with water to form carbonic acid. Odd electron molecules. The octet rule says atoms like to have 8 electrons in their outer shell, but there are some fascinating exceptions. Incomplete octet. Boron is stable with fewer than 8 electrons, like in BF3. Expanded octet. Elements in the third period and beyond, like sulfur in SF6, can accommodate more than 8 electrons. Odd electron molecules. Some molecules, like NO, have an odd number of valence electrons, leading to unpaired electrons. The octet rule states that atoms are most stable when they have 8 electrons in their outer shell, but not all molecules follow this rule. Electron-deficient molecules are molecules where the central atom has fewer than 8 valence electrons. This occurs most often in compounds with small atoms or highly reactive elements. Odd electron molecules. Some molecules, like NO, have an odd number of valence electrons, leading to unpaired electrons. The octet rule states that atoms are most stable when they have 8 electrons in their outer shell, but not all molecules follow this rule. Electron-deficient molecules are molecules where the central atom has fewer than 8 valence electrons. This occurs most often in compounds with small atoms or highly reactive elements. Expanded octet. Elements in the third period and beyond, like sulfur in SF6, can accommodate more than 8 electrons. Finally, let's explore hypervalent compounds, those with central atoms exceeding the octet rule. Examples include sulfur hexafluoride, SF6, and phosphorus pentachloride, PCl5. These molecules show how chemistry pushes boundaries, and that's a wrap on the periodic law and chemical bonding. From atomic structure to bonding and trends, we've covered it all. If you enjoyed learning with us, make sure to like, subscribe, and hit the bell icon to stay updated with more fascinating chemistry content. Until next time, keep exploring the wonders of science.